Hey everyone, so we're going to continue our discussion with talking about how to actually solve equations, in particular quadratic equations. So we're actually going to end up taking what we learned before, the whole factoring and adding and subtracting and simplifying, and we're going to relate it to equations. Now, before, in the other two units, we only talked about algebraic expressions. Remember, the main difference is that expressions refer to things that don't have an equal sign. Equations, on the other hand, will end up having an equal sign. Now, there are linear equations that you should know how to solve. They're pretty straightforward. These are things where you only have one variable, and that variable has a power of 1, and that's pretty much it. So a good example is something like this: 5x minus 2 equals 3, or 4x plus 3 equals 2. Now, you should know how to solve these. It's that whole idea of isolating the variable. So you move these terms over until you get x equals blank, and that's pretty much what you're looking for. That's what we call solving the equation. So first step would be to isolate the variable. So if we use the scenario that we had before, I believe something like this: 2x plus 3 equals 4. We would isolate it by using our PEMDAS operations. But the difference is we actually go backwards. So what we're going to do is do all the addition subtraction. So I'm going to move this 3 over to this side. So I get 2x. This cancels out to 0. And then I'm left with 4 minus 3, or 1. And then I go to the multiplication division. So I'm going to divide a 2 over to the other side so I can get rid of it here. And I get x equals 1 half. So remember, the whole idea with an equation is whatever you do to one side, you have to do to the other. And if you have something like this where 2x is being added to 3, then to bring it over, you have to do the opposite of addition, which is subtraction. And then whatever we get as an answer, that's going to end up being our solution. This is so that if we take this number and we plug it back into the original equation, we get a true statement, which if you do plug this in, 2 times 1 half plus 3, plug that into the calculator, you do see that it's 4. Now, one thing to note, because these linear equations, there's only one x and there's the power is to 1, we only get one possible solution. All right. Now, in math, as you know, we do have special names for some of the polynomials, in particular, the ones that have higher exponents, and this is all based off of their degree. So, for example, a polynomial that has degree 0 is what we call a constant. So, 4, 5, 7, those are degree 0 polynomials or constants. We already talked about this, but degree 1 polynomials are called linear polynomials. So like 2x minus 6. Degree 2, which is what we're going to talk about in this section, are quadratics. So that's where we have the highest exponent being 2. You could also think of these as being trinomials, but quadratics is a better term for this. And degree 3, for example, we might talk about this later, but these are called cubics. So highest exponent is 3. All right. So like I said, we're going to focus mainly on solving quadratics. Now, as you should know, quadratic equations or quadratic expressions are always written in this form: ax squared plus bx plus c. So anytime we have a quadratic, we're going to want to rewrite it into this standard form. Now, in order to solve this, the first thing that we want to do is get into that standard form. What we want to do is be able to get it so that everything's on one side of the equation and then the other side is 0. We're not going to be able to solve it if we don't do this. So for example, here, I have a 12 on this side. I'm going to want to subtract it over so that I get a quadratic on one side and a 0 on the other. All right? Step 2, now what we're going to do is use what we just talked about in the last unit and factor that left-hand side. And we're going to factor it so that we end up getting two binomials that equal to 0. Now, The reason this is important is because, as we know, in order to get 0, that means either this term equals 0, this term equals 0, or they both equal 0. So if we can figure this out, a number that could either make this term 0 or this term 0, then we can find our solutions. So what we're going to say is that we're going to set each of these factors to 0 and then solve it like a linear expression to get our solutions. So I'm going to take the x minus 4, set it equal to 0, and the x plus 3 equal to 0. Because this is x minus 4, I'm going to do the opposite and add 4 to both sides. And over here, because this is plus 3, I'm going to again do the opposite, minus 3 to both sides. And I end up getting x equals 4 here and x equals negative 3. So my solutions would actually be written like this. We would use these curly brackets and we'd write negative 3, 4. Standard form, you usually put the smallest or negative number on the left and then the positive bigger number on the right. One thing to note, because these are quadratics, we end up getting 2 solutions. So that's important. You should pretty much always get 2 solutions unless the solutions are the same number, which you might see a few times. All right, now, one good step to do is at the very end, once you get your solutions, just double back, plug those numbers back into the original equation, and see if it actually holds true. So if you plugged in negative 3 or 4 into the original equation, which I believe was x squared minus x equals 12, you should end up still getting the same number. So for example, if I put negative 3 in for 2 in here, square it minus negative 3, I end up getting 9 over here. I get minus negative 3, which is just plus 3, which does equal 12. And if I did the same thing with the 4, I would get, again, the same number. All right, so pause the video, work on these yourself, and we'll go over in a second. All right, so what we're going to do is we're going to move this over. So we got 2x squared plus 24x. And then I'm going to subtract the 90 over. And I get this as my quadratic. Now remember, when we go to factor, the first thing we want to do is greatest common factor. So I could divide a 2 out of all these numbers. So that means I have a 2, and then I'm left with x squared plus 12x minus 45 equals 0. 2. Now in here, what we're going to want to do is the AM method. So remember, we're going to have to find 2 numbers that multiply to negative 45 and then add to positive 12. So there's negative 1 and positive 45. Negative 2, or 2 doesn't factor into 45. 3 does though. So negative 3 and plus 15. And from here we can actually see that if we add these 2 numbers, we do get positive 12. So my factor would be x minus 3, x plus 15. Now, I would set all these equal to 0. Because this is a constant term, I just pretty much drop it out. It doesn't mean anything. So what I care about is x minus 3 being equal to 0 and x plus 15 equal to 0. Again, minus 3, so I'm going to add 3 to both sides. And I get x equals 3. And over here, I get minus 15 to both sides. And I get x equals negative 15. So my solution would be negative 15 and positive 3. Now, one thing to note, a quick way to actually getting to the answer is once you figure out these 2 numbers, you just take the negative, flip the signs of them, and you'll get your answer right away. So you can actually do that as a quick way of getting to the answer if you didn't know, which is one of the reasons why the AM method is really nice to keep in mind. All right, so for here, so first thing I want to do is simplify. I have to distribute the x to both of these terms. So I get an x squared plus 7x minus 2 equals 28. I'm going to want to subtract 28 to both sides. Now there's already a constant over here, so what I'm going to do is plug that into my calculator. So I'm going to do negative 2 minus 28, and I end up getting negative 30. Remember, don't be afraid to just use a calculator just to double check the work. You just want to make sure you have the signs in the right spots. All right, so from here, I'm looking for two numbers that multiply to negative 30 and add to positive 7. So that means the bigger number is going to be positive. So we have negative 1 and 30. That equals to 29, so that's wrong. Negative 2 and 15. That's going to equal to positive 13. That's wrong. 3 and positive 10. Add those up, I get plus 7. So that's going to be my answer. So my factor will end up being x minus 3, x plus 10 equals 0. So set these two factors equal to 0. And you're going to end up getting x equals 3 over here and x equals negative 10 over here. So my solution set will end up being negative 10 and 3. Now, you might be asking, why am I going through all this effort when I could just take the numbers here and flip the signs? That's fine if you're doing a multiple choice question and that's all you had to do, just find the answer. But if I'm asking you to show your work, you will have to show these steps. You would have to show you factoring into these two parts. You would have to show that you set each factor equal to 0, and then show how you solved each one to equal 3 and negative 10, and then write it into the curly brackets at the very end. This is literally the minimum amount of work that you would need to show to get credit for showing your work. All right? Keep that in mind. Here's the next set. Pause the video, work itself. I'll go over in a second. All right, so from here, this is actually a fairly easy one to factor. There's nothing on the right-hand side, so I can actually do greatest common factor like I would normally. 2x is the greatest common factor. I get 2x, and then this would be 3x, and this is just 1. So I get 2x times 3x minus 1 equals 0. Now I do the same thing. I said this equal to 0, and I said this equal to 0. So 2x equals 0, and 3x minus 1 equals 0. Now here's the nice thing. If I divide this over, x equals 0. So I have x equals 0 as one of my first factors on my solutions to this. For this one, I'm going to add 1 to the other side, get 3x equals 1, and then divide 3 to the other side to get x equals 1/3. So not every solution is going to be a whole number. So my solution set, the way I would write it, is 0 and 1/3. All right. All right. So this next one, what you would do is I'm going to actually add the 37r and the 45 over to the other side. Plus 45. And then what I'm going to get is 6r squared plus 37r plus 45 equals 0. Now, I'm not sure if this can be factored anyway using the AM with the greatest common factor. There doesn't seem to be any common factor, as 37 is, I believe, a one of the prime numbers. So there, it really is going to be no factor that all these share. So what I'm going to have to do is use the the grouping method, where I take the first and last terms, multiply them, and I'm going to end up getting 270. Now this is going to take me a while because I'm going to have to go through a bunch of terms before I can get to one that's close to 37. So 1 and 270, that's not it. 2 and 135, that's not it. 3 and 90, that's not it. Then we can do 5 and 54. We're getting a little closer, but that adds up to 59. So let's see, 6 is a factor, but it's 6 and 45. That adds up to 51. Let's try 7. 7's not a factor. 8's not a factor. 9 is. So 9 and 30. That's 39. So 270 divided by 10. And here's our winning number, 10 and 27. So if I add these up, I do get 37. So my new polynomial is going to be 6r squared plus 10r plus 27r plus 45 equals 0. So we do the grouping. So 6r squared plus 10r. The greatest number that I could pull out is a 2r. And then I'll be left with 3r over there and 5r over 5, sorry, over here. And then on this side, the greatest number that I could pull out of there is going to be a 9. And I'll be left with a 3r and a 5. So my factor will end up being 3r plus 5, because remember that's the common term, and then the 2r that I pulled out of the first one, and the 9 that I pulled out of the second. I then set these two equal to 0, so I'm going to run out of space. 3r plus 5 equals 0, and 2r plus 9 equals 0. Moving things around, subtract the 5 over to the other side. 3r equals negative 5. Divide by 3. And I end up getting r equals negative 5/3. I want to keep it in the fraction form. Over here, subtract the 9 to the other side. 2r equals negative 9. Divide both sides by 2. And I get r equals negative 9 halves. So my final solution for this will end up being minus 9 halves minus 5/3. And like I said, we could double check, plug these numbers into here, and see if we get the same number. Basically, we want to end up getting something like 5 equals 5. All right. So here's the last set of questions. Pause the video, work on itself, and we'll go over in a second. All right. So what we're going to do is the same thing that we did before. So here I'm going to distribute the x to both sides. I get x squared plus 10x. I'm also going to end up subtracting the 8 to the other side. So minus 16 minus 8 gives me negative 24. And that's going to be equal to 0. So from here, two numbers that multiply to negative 24 and add to 10. Negative 1 and 24. That will add up to 23. Negative 2 and 12. That adds up to 10. So my numbers are going to be x minus 2 and x plus 12. So setting them equal, x minus 2 equals 0 and x plus 12 equals 0. So I end up getting x equals 2 and x equals negative 12, which when written in our solution set will be negative 12 and 2. Down to number 6, again, do the same thing, distribute those numbers over and subtract the 1 over to the other side. Now, you should separate these into two different steps, but I'm doing it so that I can keep these videos a little bit shorter. From here, then again, I'm going to factor. So two numbers that multiply to 1 and add to negative 2 will be negative 1 and negative 1. So this is x minus 1, x minus 1. Because of the fact that these are the same factor, I only have to do this work once. X minus 1 equals 0. And I end up getting x equals 1. So my solution set here would be 1. So as I said, even though quadratics, technically we have two solutions, sometimes those two solutions can be the same number, like in this case. All right? And that's pretty much it. So again, we're taking what we just learned in the last unit and expanding it to see how to actually solve quadratic equations. Now here's some exit questions. It's a little bit wordy. The first one, what you're going to do is basically write out how Barry can solve this equation. So what does he have to do? List the steps. And then number 2, basically talk about the different methods that we have of factoring polynomials. And then look at, state some things that we have to check for first. And again, make a list. So you can pause the video, throw your answers in. If you have any questions, please let me know. Don't forget to join the Remind and join me during my extra help. If you need any help, ask me in class. Just again, reach out. You want to make sure that you're remaining on task. Otherwise, good luck, and I'll see you later.